When I go about with a lesson plan, I always begin with the end in mind. Um, what do I want my students to walk away with? What are my learning outcomes? In other words, when the student walks away from the class, will they go, wow, I learned, like it's very South Park, I learned something today. What did I learn? What will I go, I'm going to use that in my life? What's the strategy now? What is the tactic? Meaning, how do I make them learn that? Problem sets and reading and doing the math in the book is a tactic for the strategy, right? If the strategy is learn physics, then design thinking would be the tactic must be hands-on, project-based, collaborative, and get people outside. So if that's the case, then what tactic now can I use? How do I structure a project, a reading assignment, a problem set that makes them do that?
So the first thing I think is you need to pull through to the content, right? You need to be able to connect whatever the design domain is back to the content that you're trying to teach. So if you're teaching physics, right, you need some kind of, probably mechanical, physical system that you want to design. If you're teaching computing, you need to talk about, designing programs or websites or applications. So the first part is making sure that your design domain is connected to your content. I think the second part is you need to make sure the design domain is connected to the student, right? So in the case of building a bridge, out in Afghanistan, for example, maybe the students can't relate to that as much as they can relate to, building a new gymnasium in the school, for example, right? And so you want to make sure that you can connect the design, or to the extent that you can, connect the design to something that the students can wrap their heads around, right? That's contextualized for them. Because that context, that design context, provides a lot of external information that the students are going to use, right? Again, design isn't just learning the physics, right? It's applying physics in that broader context. And so the better that those students can relate to that context, I think the richer that design experience will be for them.
That's what I think is the first thing to do, to think about what do you want your students to look more closely at, and what categories can you give them to look at things from. So for example, we want students to look at the design of products here at the School of Industrial Design. So imagine we want students to look more closely at a toaster. So we said, okay, so study this toaster through these different lenses. Study it compositionally. What are its forms and spaces and proportions? Study the materials of the toaster. How is it sustainable? What is not? What is magnetic? What is burnable? What will last forever? What will disappear in a short amount of time? Now think about the users, how it's used and operated. How is the toaster used at breakfast? What role does the toaster play in the kitchen at night? And to think about it through these different lenses. So I think the first step is to identify what do you want your students to spend more time looking at more closely, and what lenses can you give them to look at that more closely. At the same time as you're having them look closely, think about what they should make. I'm a huge proponent of visual thinking. So if students are thinking, the toaster is shaped like a square, they should be able to simply draw a simple idea of a square. If they want to say that the toaster is used in the morning one way, that's used very differently at night, they should be able to make a little stick diagram that indicates that. Then when you take students' observations and you put them all together and categorize them, likely you'll have a very, very rich conversation. Students that look closely at what you wanted them to look closely at, and they're able to describe it in different ways, and you've got visual evidence of this, of their looking, so you know what they see. So once you do that first phase where you're really immersing students in the process, helping them to look more closely at the problem, then you help them to reframe the problem. So what kinds of solutions might grow from this? If a student realizes that the toaster actually serves as a mirror for someone to put on their makeup in the morning, maybe that starts to change the way that the product can be used. Maybe if we realize that actually counter space is really important in the kitchen and we don't need this toaster, maybe we devise a system so that the toaster appears and disappears, rises and lowers, transforms to something else. So students are able to see things differently, and then they're able to understand each of those categories as a window to a potential solution. And during this time when students are trying out ideas, they don't just think about ideas and talk about them, they make things. So they test ideas. So I want to test a toaster that rises and lowers in my cabinet. So a student will simply make a simple prototype model where they test that idea. And they test it out themselves, and then they might test it with users. So they might take it out and say, what do you think about a toaster that would work like this? And they can check and talk with clients and potential users and see what works. After students get feedback, they do that research from making a prototype, they modify it, and then they try again. So they keep on working through this process of thinking and making, testing, and changing. So our goal is to fail fast. We want to find out what the mistakes of this idea are so that we can improve it and make it better. Design process involves that experimenting, testing, refining, making it better.